Measures of spread 2, standard deviation. Standard deviation measures the average deviation or spread from the mean of all values in a set. It is a reliable measure of spread as it takes account of all values in the set, unlike the range or interquartile range. So the range only takes account of the largest number and the smallest number, and the interquartile range only takes account of the difference between the upper quartile and the lower quartile. So standard deviation takes account of all values in the set. However, if there are extreme values in the data set, so extreme values being either very high values compared to the rest of the data or very low values compared to the rest of the data, it is best to use the interquartile range, which we've already covered in previous videos. Okay, so this is the formula for standard deviation, and this is an explanation of what all the symbols mean. So this symbol here, it's like a circle with a little line sticking out the top of it. This stands for standard deviation. So standard deviation equals the square root of the sum of, so this kind of E symbol represents sum of, so add together, x, which is the variable, minus x bar, which is the mean, all of that squared, divided by n, which is the number of the variables or the amount of the variables. So this formula is given to you on page 33 of your formula tables, but it is written slightly different. So this is the formula that you'll see in your formula tables. So the only difference is this little symbol here. So it looks like a U with a little line in front of it, and it represents the mean, and also on page 33 is that symbol, and written to the right hand side of it says mean. And obviously x bar in our formula given in the book represents the mean as well. So it's only slightly different formula in your formula tables to the book. This is the only thing that's different, but it represents the exact same thing. So standard deviation equals the square root of the sum of the variable minus the mean squared divided by the number or the amount of variables. Consider the sets A, which equal 8, 8, 9, 11 and 14, and B, which equals 1, 3, 8, 17 and 21. Calculate for both sets the mean, the range and the standard deviation. So the mean of set A, so remember x bar represents mean, so the mean of A is going to be 8 plus 8 plus 9 plus 11 plus 14, all divided by 5 because there was 5 values in total, which is 50 divided by 5, which is 10. So the mean of the first set of data is 10. Now we're going to get the mean of set B. So we have x bar, which again represents mean. So the mean of set B is going to be 1 plus 3 plus 8 plus 17 plus 21 divided by 5, again because there was 5 values in this set, which is also 50 over 5, which is also 10. So we just have a coincidence that we get the same mean for both sets of data. Part 2, we want to work out the range. Both sets have the same mean. They both have a mean of 10. But the members of set A are more tightly bunched around the mean than the members of set B. So if you go back and have a look at set A, so remember we got a mean of 10, and all of the numbers in set A are quite close to 10. 8, 8, 9, 11 and 14, they are all quite close to 10. So they are more tightly bunched around the mean. But in set B, which remember we also got a mean of 10, we have numbers that are much further away from the mean. So for example, 1 is quite far away from 10, 3 is quite far away from 10, 8 is close to 10, 17 is quite far away from 10, and 21 is very far away from 10. So set A, the members of set A or the values of set A are quite tightly bunched around the mean, which is 10, whereas this is not the case with set B. They're much further away from the mean. To measure the spread of values, we could use the range. So the range of set A is going to be the biggest value, which is 14, minus the lowest value, which is 8, and 14 minus 8 is 6. So the range of set A is 6. Then to get the range of set B, it's the largest value, or the maximum, which is 21, minus the minimum, which is 1, and 21 minus 1 is 20. So the range of set B is 20. So even though both sets had the exact same mean, their ranges are very different. The range of set A is 6 and the range of set B is 20. So now we're going to find the standard deviation. So for standard deviation, this gives us an indication of spread and indicates that set B has a much greater spread than set A. So the numbers are much more spread out in set B than they are in set A. However, as a measure of spread, the range is limited to just using two values in the set, the maximum value and the minimum value. Standard deviation, however, uses all values in the set to calculate the spread and is therefore a much better measure. Here is how the standard deviation is calculated for set A. So step 1, write down the difference between each member and the mean. So what I'm doing is working out what's inside the brackets from our formula first. So x represents the variable or the member of the set. In set A's case, 8, 8, 9, 11 and 14. And x bar represents the mean, so it's going to be each variable minus the mean. So remember, we got the mean of set A and the mean of set B to be 10. So it's going to be 8 minus 10, which is minus 2. 8 minus 10, which is also minus 2. 9 minus 10, which is minus 1. 11 minus 10, which is 1. And 14 minus 10, which is 4. So I've worked out what's inside the brackets of our formula. So next we're going to square it. So step 2, square the numbers. So minus 2 squared is 4. Minus 2 squared is also 4. Minus 1 squared is 1. 1 squared is 1. And 4 squared is 16. So what I did was I worked out what's inside the brackets first, and then I squared my answer. Step 3, find the mean of the squares. So this is where the sum of symbol comes into play, and also the divide by and the n, which is the amount of values. So sum of means we add these all together, and then we're going to divide them by the amount. So it's going to be 4 plus 4 plus 1 plus 1 plus 16, all divided by 5, because remember we had 5 values in our set, which gives us 26 over 5, which is 5.2. So now we've worked out all of this, and now we just have to apply the square root. So step 4, find the square root of this number. So the square root of 5.2 is approximately 2.28, rounded off to 2 decimal places. So the standard deviation of set A is standard deviation of A, approximately 2.28. Similarly, by following the procedure above, we can find the standard deviation of set B to be approximately 7.80. Set B has a greater standard deviation because the members of set B are more widely dispersed or more widely spread than the members of set A. So we got 7.8 for the standard deviation of set B, which is greater than 2.28, which is the standard deviation for set A. So this formula is given to you in your formula book, and it's important to follow the steps following BODMAS or BIMDAS or BIRDMAS, whichever way you learned it, which means we do what's inside the brackets first, then we square it, then we add them together and divide by the amount, and then at the end we apply the square root. So just to recap, step 1, we got the difference of each of the member and the mean. So we got the mean to be 10, so it was 8 minus 10, 8 minus 10, 9 minus 10, 11 minus 10, 14 minus 10. And our answers were minus 2, minus 2, minus 1, 1, and 4. So step 2, what we did was we squared these numbers. So minus 2 squared gave us 4, minus 2 squared gave us 4, minus 1 squared gave us 1, 1 squared gave us 1, and 4 squared gave us 16. Then step 3 was we got the mean of the squares, so we added up the 4, the 4, the 1, the 1 and the 16 and divided by 5 because there was 5 of them. So 4 plus 4 plus 1 plus 1 plus 16 is 26, and 26 divided by 5 is 5.2. And step 4, we got the square root of this number. So we always apply the square root at the very end. And the square root of 5.2 was approximately 2.28 to 2 decimal places. And to find the standard deviation of set B, we did the exact same steps, minusing 10 to each of the values, squaring each of the answers, adding them all together and dividing by 5 because there's 5 values, and then square rooting our answer. So use this formula to help you follow the steps, but remember you do need to learn off the method. So we can actually summarize that method in a table, and this can be a bit easier to figure out. So we'll have our row along the top being x, which is the variable, x bar representing the mean, d representing the difference, and d squared representing the difference squared. So remember for set A we had 8, 8, 9, 11, 14. So 8, 8, 9, 11, 14. Our mean of set A was 10. 8 minus 10 is minus 2. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 11 minus 10 is 1. 14 minus 10 is 4. Then we squared each of the differences. Minus 2 squared is 4. Minus 2 squared is 4. Minus 1 squared is 1. 1 squared is 1. 4 squared is 16. Then we added up all the different squareds. And 4 plus 4 plus 1 plus 1 plus 16 is 26. And then we divided 26 by 5 because remember there's 5 variables in our set. And we also applied the square root. So 26 divided by 5 is 5.2, and the square root of 5.2 is approximately 2.28 rounded to 2 decimal places.